Good evening, friends. My name is Sandeep. Today my topic is about low energy security limits and opportunities in the Internet of Things. Procedure wireless is technique coupled with device miniaturized has led to preserved communication. Fabric encompass everything from automobiles and environment sensor to medical device and personal communication. Consequently, computing is become centralized on the huge amount of information captured and made accessible by the vast arrays of devices. For that, from the Internet of Things, IoT allows for new applications that will tackle societal needs through unprecedented access data. However, the new technology energize every increasing rate. There will be commensurate increasing in cyber attacks. Unfortunately, it's impossible to design applications that engender trust in their effective without trust. Is underlying operation, connectivity, and data processed by Internet of Things. The phones which are well resourced and can be readily powered and recharged. However, it will also include embedded wireless devices in previous unconnected world for the resource paradigm quite different. These devices must be highly affordable and their size will be limited in terms of energy computing size and storage. In this article, the viewpoint of the low end of the IoT as the operating energy computing, the regime aren't connectivity traditional security. Computing the will characterize the edge of IoT will common considerable functions. Device must devote most available energy commuting exiting core applications functional and might have little left over support security and privacy. IoT a natural starting point for identifying IoT security concerns is prior work on wireless and HOC sensors network security. Many security concerns that IoT are facing undefined the researching duckling of the future security of embedding wireless device and examine confidently. Integrate simply swings the security protocols for sensors network provide a detailed exploration in the content of highly resource constrained smart touch sensor. The confidently wireless communication between the internet and the attacker and the suspected very confident threats for attackers snooping for message broadcast over the air malicious adversaries can easily intercept packets for and communication device and decides the listening of integrated authentic and non-republic IoT device integrated electronics and the various levels of that requires authentic devices and thereby supports ensures integrity of the message communications between the senders and receivers. Availability of addresses are launched RF service which are the IoT ability to transmit or receive message similarly to operate with a faster duty cycle thereby increasing the utilization of flooding back end server. The IoT involves in unpredicting internet of objects. Many of these devices will be semiconductor manner with our very limited maintenance as the IoT substance previous separate nations of sensor networks mobility and works RFI systems securing the IoT will require techniques support the areas of new ways. Energy concern can be easily solved by other technologies. The IoT device range for low RFID transponders to more resourced smart and tablets. We focus on most lightly resourced and inexpensive devices. Engineering work that with platforms such as smartphones and tablets far easier task than those beginnings to work with new generation IoT nodes. Considering that device between smartphones, the humidity for decades, Smart has 2.5 GHz and core processor 2 GB of and 128 GB of SD and battery 30 kg stored energy that typically recharge daily. The tag has single 16-bit processor often running 6 to 12 mHz to save energy 125 byte not megabyte or gigabytes but bytes of RAM 16 KB of flash programming storage. The phenomena runs roughly 10 hours while web nodes. But the IoT nodes must deliver data over wireless links for at least 10,000 hours on a coin cell battery with less than 1 by 15 the energy of the phone and it never gets recharged. A few million instructions executing security protocols is insignificant drains on phone resource but would be intolerable for tag. Three approaches address this problem. The first approaching widely several recent energy brings the demonstration of showed that the attackers can hack passive sensors cars. In other case, attackers passively read wires, electric meters, residential applications, the details, and it has it has the wireless of hundreds of meter developing details pattern. Therefore, there are used issues to more emerging widely developed. Another approach to address this process is adapt the miniature device after the small device ever denser circuit for reach fundamental limits. The official semiconductor roadmap shows size has full 7 and placing limits on the can be produced reliably on watt wafer of the course promising performing process will be containing new materials. However, the smaller size in reaching natural and process will be slower, able to less benefit and this advance until technology becomes mainstream long after the hundreds of thousands nodes per person. Like the next area of performance increase expected disappoint likely. So unlike semiconductors, batteries are mature. The periodic table offers limit number of elements and their potentially for making batteries as long has increased useful battery capacity of only 7% per meter and were already utilized some of the highest energy material getting just one of the many decades per performance highly unlikely even with alternative energy storage and technology. As you can see the diagram of the figure 1 of the battery technologies over the 3 decades. For example, Tesla automobiles Li battery report to have little than 1000 watt hours kg consistence of Li ion curve and figure there are strictly limits on amount of the energy can be stored and potentially risk. We can verify the limits examining principles. For example, we can verify lithium fluoride calculations formation in the National Institute Standards and Technology Chemistry web book and converting watt hour kg. Environment for the man-made natural resource in case of systems. IoT nodes efficiently these systems into two broad categories: low frequency electromagnetic energy, which is based stations in the wavelength to the sensors. The coupling efficiency decreases rapidly. A good rule of thumb is useful on the few times size of antenna, making it of limitly utilizing for powering remote IoT nodes. The second type of add energy systems use gas provided frequency electro radiation enter this IoT node powering a system to radiate. Energy is an old idea that has practical limitations when the low cost small IoT needs RFID tags where the few hundred megahertz, a few gigahertz passive tag. The tag collection energy with antenna converts it into DC electric energy to communicate back with the base station. The modulates characters of antenna changing the unfortunately RF energy reflected to the station. Unfortunately, the relative safety regulations several limitations capability of the fundamental constant radio energy decrease in density by at least the square distance because the real world attention omnidirectional must be provided to the base station. Performance low expect and range few meters for the instant. A base station emitting 4 watts to provide IoT RFID tags and IR3 environment which frequently occurs in indoor and in the far and the reflects back. Its situation becomes even more extensive of the safe legal experts limits. The large radio energy is needed just allow a node modulate the radio signal and the reduce power level using the direct beam along the lines side, but the dangerous severely limits of the IoT develops option. The second approach for the energy harvesting is to try into existing energy source. A curious look at the most environmental rebels and apparent wealth wasted light, heat, vibration and wind and so forth. Similarly, there are many examples of full harvesting of those resources, all those particle limitations of IoT, but we focus here on the harvesting as it appears easy to implement and scale need of IoT. At noon and clear, the sun provides nearly 100 photovoltaic cells convert into the energy usable electricity with the efficiency that range from high of nearly 25% in the single. Although the harvesting limits usefully necessary miniature low cost sensor. Firstly, the sun is up to the daytime. Behind this is clouds, so shadows and the sun motion acclimate, which further limit output to small fractions of theoretical maximum per instant. The observed daily solar gather network city average of the event, so there might be useful amount of the nodes. The character probably instant of the applications which are such as harvesting light. Example they include bridges, corrosion, water leaks, and objective trackings, and other which IoT nodes are placed space generally occupied. An example to IoT energy device requirement breakdown. How IoT nodes there are previously joules to accomplish their task. Let's walk through the energy budget of low power long lived sensor. For the example, estimate energy to send the easy read from and the framed into packet with decode information must be moved from the processor to the radio, a complex device the typical which must be powered tension of the then the actual data must be sent over the air. The last step is typically under 10% efficient for commercial chip, although some protocol research devices have shown nearly 50% efficiency. We exam based on MCU radio load device in character simple class of IoT device based on Texas Instrument megahertz are requiredly and CC1150 absolute 23 MA board frame 8 sync and 1 byte 3 byte ID and 448 which are 23 milliamps plus 2.8 milliamps for the microcontroller would be the energy to validate the which attached to the device with regular 3 volts power supply in line 10 resistor and measured in the oscilloscope. Figure that measurement and the frequency synthesizer schedule time the radio broadcasting using approximately 75 percentage of the MUC data and the delivering approximately 25 percentage the no provision encoding at the microcontroller 16-bit operation at the MHz using approximately megahertz and will be double MUC and the word give a security engineering less than 20,000 operation 16-bit to ensure the security validated to ensure recently light and SSL implementing the device required roughly 16 million operations. Convention cryptograph fails to prot the convention cryptograph is instantly secure the internet. We were big fans of using cryptograph to protocol suites such as IPSC, EC and TLC, HTTPS on well users device and the ultra low perhaps foremost the challenge basic encrypted algorithms such as block such low end device and IoT have 12 byte of RAM very limited. Some of this memory will have be related to storing any cipher keys memory to detect no core functions in the tablets for efficient implementation. Not rhythm involves largest box permanent tables. The typical advanced encrypt standard ranging involves 800 bytes of look tables and more efficiently implementation requires even more storage for lookup tables. Thank you.